All right, find this page in your packet or write these problems down, pause the video and try both problems. So for number 1, evaluate f of -4. Since the remainder is -7, that is the value. This is from the remainder theorem. For number 2, to factor and find all zeros, well, first let's set the equation equal to 0. Then we've got a higher power quadratic. So what multiplies to -36 that adds to 5 will be +9 and -4. Then we're going to set each factor equal to 0. You could factor this difference of squares more, but since we're solving, I'd rather use the square root method. So we get x squared is 4. X is plus or minus 2. X squared is -9. X is plus or minus 3i. So let me check. This degree is 4. So the total number of zeros, real and complex, should be 4. And I have 4 answers here. All right, our reminders for the day. It's this short week. We have a check-in time Thursday afternoon. And the homework assignment that we're going to get to at the end of this video is due today. You're going to use the time today to get this done. There will be a quiz this weekend. So we're going to use the information provided to write the equation for each polynomial. We're given the degree, the root, and the leading coefficient. Equations must have a y equals, an f of x equals. We need our leading coefficient. And then I'm going to check the number of roots I have. Is that the same as the degree? Yes, it is. So I can write my equation. That's x minus the root. So I'm going to have plus 2x. Now, this 1 is a repeated root. So I'm going to square that factor. Number 2, we have our leading coefficient. I'm going to start with these real roots, but first let me check, do I have them all? 1, 2, 3, 4, I do. So that's x minus 4. And now these complex roots, I have to figure out where would they come from? So I'm going to work backwards. Let me get some space down here. I know the answer would be 2 plus or minus I. If we solve, we should get 2 plus or minus I. Well, now I have to figure out what factor did that come from. So I'm going to take the 2 and move it back over here with the x. Then to undo this I, to change that back, that would have been plus or minus the square root of -1. But now to get back again, I'm going to square both sides. So x minus 2 times itself. That x squared, -2x, -2x plus 4. And then we know to solve, this would have been equal to 0. So if we add the 1 to the right side and combine our like terms, that factor would be x squared minus 4x plus 5. So if I was given this factor, I would have solved it to get these 2 answers. So let's go put that in our factored form. All right, now for 3, it says we have a degree of 2, but I only have 1 root here. I know because to solve to get a root of square root of 2, I'd also have negative square root of 2. So we got y equals -1. And I don't want to put the square roots as my factors. That we don't have factors with those radicals. I'm going to do the same thing we did for number 2, but now with the square root. If x would have been plus or minus root 2, what factor would have gotten us there? So let's square both sides. Make it equal to 0. So that x squared minus 2 would be the factor that if we solved it, we'd get plus or minus root 2 as our answers. Okay, let's use the factored form and the multiplicities to graph our equations. We've got an odd degree with a negative leading coefficient. So we got the end behaviors like this. We've got roots at -2 and 1.
I don't see anybody.
And then the -2 is that single root from this factor. So we go straight through. And then since -1, x minus 1 has a multiplicity of 2, or it's a double 0, we're going to be tangent at 1. So in number 2, we can't see these complex numbers in our x-intercepts, just the real values. We've got an even degree, positive leading coefficient, so both end behaviors will go towards infinity. Both are a single root. I missed. There we go. We go through those intercepts. And then lastly, even degree, negative leading coefficient, both our end behaviors will point to negative infinity. Label my x-intercepts. And then this graph will go something like this. Okay, so now on the next page, let me make that fit. We're given some information depending on the problem. So take a look at number 4. Fill in anything you can figure out here. Pause the video, fill in any of the blanks that you can figure out. All right, so I'm going to first start with my degree. This would be x and x squared. So that's a degree of 3. My leading coefficient is a positive 2. So that means odd, positive, negative infinity to the right. Our y goes to negative infinity. And to the right, did I say that? I said that wrong. As x goes to negative infinity, this is left. Y goes to negative infinity to the right. As x goes to infinity, y goes to infinity. Okay. My roots, I've got a 1 and then the repeated -3. So at -3, we're going to be tangent. At 1, we're going to cross through. For my domain and range, now that I have the graph, I see my domain is x is all reals, and so is the range. All right, pause the video here. Try everything you can for 5. I see we're given the roots and the leading coefficient, so I'm going to start with my equation. is that x minus 3, it's a single root. I'm sorry, that's a single factor with one root. Negative 1 is a double 0, so I'm going to do x plus 1 squared. And then 0 would be x minus 0, x plus 0. So I have just x squared. Our degree, we've got 1. If I was going to think of this in standard form, we'd have x squared, and x squared. That's a degree of 5. So same end behavior. Oh, actually, no, we got a reflected end behavior. So negative infinity goes to positive. So these will flip, reflected. And then negative 1 is tangent. 0 is tangent. And 3 goes straight through. So again, our domain is x is all reals, y is all reals. Okay, now for 5, go ahead and now we're given a graph, pause the video, fill in any of those properties you can figure out. I'm going to start with my multiplicities and my roots. I've got negative 2 twice and positive 2 twice because those are both tangent. And behaviors both point to infinity. So let's see, the leading coefficient is 1. And my factors will be x plus 2 squared, x minus 2 squared. So that's a degree of 4. So with this graph, I can actually see the max and min of my y's and x's. Domain is still going to be all real numbers. The range, the smallest y value is 0, and then it goes up. So we're going to have y is greater than or equal to 0. Okay, 7. Factor the polynomial and sketch the graph. Pause the video and try that. All right, there is a greatest common factor of x squared. So my roots are 0, 0, and 1. Odd degree, positive leading coefficient gives us this end behavior. So we're going to go tangent, cross through. Okay, so on 8 through 11 here, I want you to pause the video and try these sketches. See if you can make a sketch with these properties. All right, for 8, does your sketch look something like this? Odd degree, negative leading coefficient has this end behavior. 2 negative real roots, 1 positive. Since there's a degree of 3 and 3 roots, everything's going to cross straight through. So through, through, and through. All right, so this one's saying a cubic function. So again, a degree of 3, and maybe, I don't know if you got caught up on the 2 non-real roots. That means 2 complex roots and 1 positive real root. Well, I don't know if it's at 1, that's just here. Negative leading coefficient again, so our end behaviors go this way. And since it's 3 zeros total, we've got 2 and then 1 more. This is just straight through because that a single root. All right, quartic, that's a degree of 4. Positive leading coefficient, so both end behaviors point up. 2 negative roots and 1 positive, that's a double. Okay, so these 2 roots will cross through, and this one should be tangent. And then lastly, another degree of 4, but negative leading coefficient. 2 negative real roots again, and 1 positive double. Oh, it's going to be a reflection of that graph. Oh, I missed. There we go. Okay, this is the homework posted for you to complete today. Submit this today. It is all these problems. Show all your work.